Alright, welcome to our new video. Today we are going to go on with the topic of acceleration. So let's have a look at it. Well, if there is a change in velocity, we have an acceleration. Let me tell you something. Every car has this device that can tell you the speed of the car at that moment, but no car will give you the amount of the acceleration at that moment, because in order to know the acceleration you have to perform some calculations. So for that we need to know its formula. So let's have a look at it, but before that I want to have a look at the evolution of the formulae we have used at the moment. First we started with the displacement, which is equal to final position minus initial position. And then we went to velocity, which is equal to final position minus initial position divided by the time. It's very similar to the one of the displacement, but here in velocity the time is divided. Finally, for the acceleration we have final velocity minus initial velocity divided by the time, and that means that the velocity is going to change. That's why we have two velocities here. So keep that in mind, because in acceleration we have two velocities, not one but two. Well, as you remember, a velocity and also as displacement could be positive or negative, and it's going to happen the same with acceleration, because if we have to subtract final velocity minus initial velocity, we can get positive or negative answers. So let's see what is the meaning of the sign when that happens. And here the thing is going to be slightly different, because in velocity we said that if velocity is positive, the object is moving to the east or the right, but if the velocity is negative, it means that the object is moving to the left or to the west. But here, if velocity and acceleration have the same sign, the velocity increases. But if velocity and acceleration have different signs, the velocity will decrease, stop, and change its sign. So how's that? Well, I'll explain you that with this simulation. And well, let's start working with velocity, setting a positive velocity, not working with acceleration. And as you can see, the man moves to the right because the velocity is positive. If I set a negative velocity, the guy will move to the left. Now let's make the things a little bit more complicated. Remember, the unit of the velocity is meters per second. And now I will set a positive velocity and a positive acceleration, and you will see that the guy starts moving to the right, and his velocity increases with time. If I set a negative velocity, for instance -4, and a negative acceleration, the velocity will increase negatively to the left. So here, as you can see, the velocity is increasing to the left. But what if I set a positive velocity and a negative acceleration? Here both have different signs. So he starts moving to the right, but now he's slowing down, he stopped, and then he changed his direction. Now he's moving to the left. So what happened here? Well, the velocity tried to have the same sign as the acceleration. By the way, I want you to see the unit of the acceleration compared to the one of the velocity. The unit of the velocity is meters per second, and the one of the acceleration is meters per squared seconds. What is why there is a square there? Well, we'll have a look at that later. Now, in some exercises you will see terms like acceleration and deceleration. What do they mean? Well, if they give you an acceleration, you will work with that number as positive. For instance, if they give you an acceleration of 3 meters per square seconds in the exercise, you will use a positive number. But if they say you that deceleration is 3 meters per square seconds, when you solve that exercise, you will place a negative here because deceleration is negative. Don't forget that. Keep that on mind. Don't forget it. Okay. Now, let's have a look at the unit of the acceleration, because it's quite weird that there is a second rise to the second power. So for this, I want you to remember the unit of velocity first, and with that, for that we're going to work with an exercise. Let's suppose that you want to calculate a velocity where final position is 7 meters and initial position 3 meters. Remember, the formula of the velocity is final position minus initial position divided by the time. So this object moved from 3 meters to 7 meters, and let's suppose that this object did that in just 1 second. 7 minus 3 is 4, and 4 divided by 1, it's simply 4 meters per second. What this unit mean? What this unit does it mean? Well, it means that this object is able to move or to travel 4 meters in just 1 second. That's it. If the velocity is, let's suppose, 5 meters per second, it means that the object is able to travel 5 meters in just 1 second. Speed of light, for instance, it's 300,000 kilometers per second. It means that light can move or can travel that distance in just 1 second. But sound, it's just 330 meters per second. Sound is able to move in the air or travel 330 meters in just 1 second in the air. But what about acceleration? Okay, let's suppose that you have a final velocity of 5 meters per second and an initial velocity of 0 meters per second. By the way, when an exercise says that an object is at rest, it means that velocity it's 0. So let's suppose that this change in velocity happened in just 5 seconds. So 5 meters per second minus 0 meters per second, it's 5 meters per second. And that is going to be divided by 5 seconds. And here I want to first work with the numbers because it's easier. 5 divided by 5 is just 1. By the way, I forgot to put or place here the seconds. So 5 divided by 5 is 1. And be very careful here because a lot of people do this. They simplify both seconds and say that the answer is 1 meter. But this is wrong, and I'll let you know why. I told you that first you had to work with the numbers. So now I want you to work with the units. Remember that here we have a fraction, and every fraction is also a division. So we have to divide meters per second that are above in the numerator by the seconds that are in the denominator. Meters per second divided by seconds. And here we have a division of fractions. For that I write down a 1 here. And remember that for multiply fractions you had to, for divide fractions you had to multiply it crossly. So meters multiplied by 1, it's meters. And seconds multiplied by seconds is squared seconds. So this is the origin of that square. But what does it mean, that square there? It's a little bit odd to see it there. Okay. An acceleration of 1 meter per square seconds means that the velocity will increase by 1 meters per second for every second that goes on. Remember, our initial velocity was 0 meters per second. 0 meters per second. That was the velocity that we had at the instant 0 seconds. That means that we didn't set up the stopwatch at that moment. The race didn't start at that moment. Whatever you want to see it, the time didn't start at that moment. But if velocity increases at 1 meter per second for every second, it means that at the first second the velocity will be 1 meter per second. For the second the velocity will be 1 meter per second more, so that is 2 meters per second. At the third second the velocity will be 1 meter per second more, that is 3 meters per second. At the fourth second the velocity will be 1 meter per second more, 4 meters per second. And take a look at this. At the fifth second, the same that we have here, the velocity will be 5 meters per second. This was the initial velocity of our example and the final velocity of our example. So remember, this square here, it means that the velocity will increase for every second that happens. And of course, if we have a negative acceleration, a deceleration, the velocity will decrease for every second that goes on. So well, that's all for this video. I hope you could get it, and we will work a lot with this in our classes. So if you couldn't understand something in our exercises, well, with pleasure I'll explain you. So goodbye.